Don't let that out of order is okay. Two lines within the same plane that never intersect. So here's a plane, and this line is on it, and this line is on it, and they never touch. What can we say about them?
They're parallel.
They're parallel. So you don't need me.
What?
The joke. You're doing great. All right. Which of the following is a defined term? So in a previous lesson, this is where I was like saying, hey, you got to know how to look this stuff up. An undefined term is a point, a line, and a plane. Point, a line, and a plane. So which of these must be defined?
Angle.
Angle. So sometimes you have to go with what is not and decide, which one it is to decide which one it is. Okay. All right. So I want you to read these 4 steps to yourself. Each one. I know they won't mean much, but I'll let you do that and then we'll talk.
All right. All right.
All right. So here's how we construct an angle bisector. I'm gonna draw an angle bisector here, and you're going to maybe see which one is correct. So you start at the vertex where they come together, and you either sweep an entire arc or just the piece. Like you can lift up the pencil here, but you can imagine that there. So you swing both of these on both rays, basically. Then you go to one or the other, and it doesn't matter which one, and you swing an arc that's bigger than halfway. That doesn't look very good. Something like that. And then you come down to the other one and you do the same thing. And there's a point where they intersect. And then you draw a line through that using a ruler or a straight edge. Okay. So now that you've sort of heard me say that, I want you to go back and either tell me which ones it can't be or which one you think it could be.
Um, well, it says use a straight edge and then use a compass. So I feel like if we knew if it was one of those, you can like get rid of 2 of the other ones.
I see. Good point there. You're never going to use a straight edge to measure the bisected angle. The only thing you use the straight edge for is for connecting stuff, never to measure. So it's one of these. So here's the vertex down here. Did we ever do anything at the vertex? Like, did we join the point where the arcs cross the vertex?
I
Do
don't
you see any arcs there?
No, not at all.
No. Did we draw 2 equal arcs from the intersected points? Here are the 2 equal arcs.
Oh, I see that now. Okay.
Yeah, this is hard. This is hard to do, but you made some good leaps there trying to figure it out on your own, and I do appreciate that. Um, so let's go to number. Now that I see this, they stopped coming in order, but there we go. There's number 5. Okay, it says which of the following is the final step in bisecting a segment? So I want you to read through these, and then I'll show you the steps for bisecting a segment.
All right. All right.
Okay, so here's a segment. So here's a line segment like this. So to bisect a line segment, you take, then you start at one end or the other, doesn't matter, and you swing an arc up here, and then you go to the other one, or I'm sorry, you swing an arc down here. So you could create a full circle where you connect the arcs, but usually just sweep one up here and down here. Then you go and you stick the sharp end in the other place without changing it. You swing two arcs, and then you now use a straight edge to connect these. So the final step here is to basically take a ruler and draw this line connecting them. So do any of these say that?
I'm looking at number 2.
Number 2 is correct, I believe. All right,
All
good.
right.
5. We may have to start doing these out of order because they just didn't come in order and it's getting too hard to. Is that going to bother you if we're out of order and we just do them in the order they came in?
No, that's totally fine.
Okay. Number 10. Kyle is creating a frame for a model car he begins by piecing two rods together as shown in the diagram. Justify why AM equals 6. So we're saying that this is 6 and ME is probably 6. Why would that be true based on what you see here? What causes those two pieces to be the same?
Well, the top is 12, so I assume if you split in half, each side would have to be 6.
Okay, so which of these says that? Split something in half or something's in the middle?
Midpoint. Definition of
Yeah,
midpoint.
you got it. All right, number 7 is the next one here. What is a necessary step for constructing perpendicular lines through a point on a line? Okay. So go ahead and read these and then I'll kind of go through the process, the construction process for you, and then you can maybe make a decision.
All right. Okay.
All right, so the idea here is like you've got some sort of a line like this. So what you do first is you just draw a dot, okay? And then you swing an arc and an arc. Both the same distance, but you swing an arc. And then you label those 2 points by just putting a dot there. Then you stick the sharp end of the compass right in there and you sweep an arc up here and up here, down here and down here, and then you draw a line between them. So why don't you take a look at these and maybe there's 2 you can eliminate, or maybe you know the one.
Well, we're talking about arcs.
Yep.
So I'm looking at the first 2 and I'm not seeing arcs, but
So they're out. So it's either draw arcs on either side of a given point on the line. Just kind of what we did here. I'm sorry, on the line, not these. Draw arcs on either side of a given point on the line. That's what, okay, so that's what we've been doing. Draw arcs on either side of a given point off the line, which kind of is these. This is one of those where you might need to go to your notes or just take a guess. Because it's kind of unclear what it's referring to.
yeah. I was thinking off the line. I guess that's my guess.
All right, we'll go with it. It's good to go with your intuition. Nothing wrong with that. And it is a leadership quality to go with what your gut says.
Yeah.
Okay, Robert is completing a construction of a square inscribed inside a circle as shown below. What should be the next step in his construction? Okay. Let me draw the square and maybe that will help to explain what to do next. I don't know, does that, maybe that will help here. Or maybe you can eliminate some.
Probably make another circle. Not,
We're not, definitely not making another circle.
yeah,
That's out.
and we're not drawing a line that's parallel.
Agreed.
Um,
So this does meet at 90 degrees. I don't know if that helps.
and it doesn't look like we're drawing arcs.
No arcs were drawn, so it must be the first one there.
Yeah.
All right, next one I see is number 5 here. Which of the following is the final step in bisecting a line segment? So well, you saw me do this earlier. So let me do it right here. Well, that is the same thing. I did it here as well. Happy to redo it, but why don't you take a look and see if maybe something stands out
Wait,
to
didn't we
you?
just do this one?
I don't know, did we?
Yeah, go back up. Yeah, right
Yeah, we
there.
did. Okay, good to know.
Guess
So
I sent
use the
two of
same
them, my
answer
bad.
from before. All
Well,
right. That's what I was worried about when I started doing it out of order. I knew I would eventually, yeah, so, uh, if you're trying, so this problem says Ben uses a compass and a straight edge to bisect PQ as shown. Which statement best explains why Ben must open the compass to a greater than half of the segment here? So it's kind of, this is one of those proofs where if you, we're gonna go, and let's just presume that that's 1, 2, 3, 4, 5, 6, 7, 8, 9. Of course, I didn't do it. Let's presume that that's down the middle. Now, if I go to this end and I swing an arc that's that length, and I come over to the other side and do the same thing, do those intersect?
no.
No. But if I make it more than half, like even if I go way too far, I still get I still get an intersection if I go more than half.
Yeah.
Because if I don't, otherwise they never intersect. So take that information and see if that's enough for you to answer this question.
I think it's the first one.
It is.
Nice.
All right, so here we go. We got angles B to A to E, B to A to E is a straight angle. That means it makes 180 degrees. The other one, which intersects it, F to A to C, F to A to C is also 180 degrees. Okay, but they intersect here. And we're interested in angle now BAC, so B to A to C, so that one right there, and E to A to F. I'm sorry, I misspoke here. I misspoke, forgive me. So actually, this is unnecessary. This one right here is unnecessary. Ignore that if you can.
All
What
right.
angle relationship best describes the angles B to A to C? So that's B to A to C and E to A to F. They're vertical angles.
Oh,
Do you remember anything about, well, I'll just give you the answer, sorry. Vertical angles are congruent. So vertical angles always meet in the kind of this X pattern.
yeah.
Any questions on that?
No,
Okay,
doing
take
good.
a look at, take a look at the next one here. All right, so we're gonna see how good your algebra is.
All right.
4x plus 2x equals 180. The reason is that EAB is a straight angle. So the angle 4x plus the angle 2x, that's to add up to 180. I want you to try solving this for x, please.
All right. So wouldn't you add the 4x and 2x together
Yeah,
to
keep
make
going.
6x?
Yep.
And then 6x equals 180, and then you divide by 6 on both sides. And then I think it equals 20. No, not 20. It's like, what is it? 90.
So here's what I mean, you said this is correct. You divide by 6.
Or wait, no, I was thinking about 2. Oops. It's 30. Right?
Yes, x is 30.
All right. I was thinking of 2 for a second. I was like, what am I doing?
Good, you did real well on that one. This next one looks like the last one you did send over. How many total are there here?
15, but I just sent you like a bunch
Okay,
before we started.
great. So it says what angle relationships describe angles BCE, BCE. So this one right here, B to C to E, so you can see that, and then C to E to D. Now, what you should try to focus on here is that they're giving you 2 lines that are parallel. Those little arrows mean parallel, and then it's cut by what's called a transversal. We looked at some of this, I think yesterday, maybe it was the day before. Any idea what these are called? Do you remember any from a previous lesson?
Same interior, same side interior angles.
They're definitely interior, okay, but they're not on the same side of
Oh, okay. I know they're
the
interior, but
so they're not on the same side.
alternate interior
Alter,
angles.
there you go.
Yeah. Okay.
And that's because they alternate, they flip over, alternate sides. You know, one's on the left side of it, one's on the right side of it.
Yeah.
All right, so that's everything that I think you've sent over.
Oh
If you
yeah.
want to send over some new ones, please do. We'll just keep
Gotcha.
going on.
All right, there you go.
So we got the last couple here. Let's load up. Hopefully you're noticing these are somewhat similar, like even though they're not exactly the same, these are kind of, we've done a few of these. So Janet is designing a frame for a client. She wants to prove to her client that measure of angle 1 equals measure of angle 3. So these are vertical angles. This one at the top, this one at the bottom, those are vertical angles. Okay, now that is not the answer. And I've made that mistake with you yesterday where I just sort of said, yeah, there's the answer. We go look for it. We're trying to figure out this part right here. Okay, so what this part on the left is saying, this is the statement. The statement is that angle 1 plus angle 2 equals 180. So if you're on the same side, the angles add up to 180. That's reasonable. Okay.
Yeah.
And then it says angle 2 and angle 3. So here's angle 2 and angle 3. These also add up to 180. So which of these down here says that they add up to 180? Or maybe which ones don't, so that you can eliminate some.
The ones I see that don't is intersecting lines. Definitely not that. Um, definitely not
So,
same side interior.
well, I'm gonna caution you on that one. Vertical angles are congruent. They don't necessarily add up to 180. So I
Yeah.
want you, internet's your friend here. Do a quick search on supplementary angles and same side interior angles, and maybe something will stand out. Or go back to your lesson notes as well. Could also be an option.
All right. Supplementary says either of two angles whose sum is 180.
Okay, so basically supplementary means they add up to 180. But same side interior angles also add up to 180. So what's the difference? Well, same side interior requires there to be two parallel lines. Is that what you have here?
Uh,
Do you have parallel lines in this picture on the,
yeah, yeah. Wait, no, no,
okay?
not that, not that, not that.
The one I did, but I'm asking about this one. Are there parallel lines?
No, there's not.
Okay, so it must be definition of supplementary angles.
All right. Yeah, my bad. I was looking at the other one.
All right, so this problem does have parallel lines. So we do unfortunately have to read all of this because make sure we get all this right. Okay, Greg is constructing a fence that consists of parallel sides ED and FB. So ED is this one here. FB is here. They're parallel. That's what the little arrows mean. Complete the proof to explain how he can show the measure of angle FAC, F to A to C, is 121 degrees. Okay. So that's this angle right here. And it is congruent to this one up here. Like those are congruent. They are called corresponding angles, but that may not be the answer. We need to actually like do what this wants here, which is to figure out, well, what goes in line one, position one. So let's look at the thing on the left here. It looks a lot like the previous one, doesn't it?
Yeah, it
Well,
does.
let's go find out where's FAC. Well, FAC is right there. ECA is right there. So this thing right here is referring to the fact that you have this angle and this angle. Now, they are supplementary, but what are they? What are they when it's two parallel lines? What did we say that was in the previous problem?
Interior angles?
Same side interior angles.
Same side. Yeah.
Okay, so that means number one is same side interior angles. And since that's the only one, well, that is the answer.
Nice.
So find the missing statement and region in the proof of the alternate exterior angles theorem. So it is given that AB is parallel to DG. The two lines are parallel. That's what these little arrows mean. And points EG, H, and F are collinear. E, G, H, and F, they all fall in the same line. Blank by the vertical angles theorem. So what did we say about that's always true about vertical angles in a previous problem?
Equals 180.
That's supplementary.
Oh, it was vertical.
They are congruent.
Really?
Vertical
Okay.
angles are congruent. Problem is that the first statement says that they're all congruent. So we got to go in and actually look at them. And remember, they meet at an X. So once you look at the drawing, is EGB and EGA, do they meet at an X? And when I say X, they have to be kind of opposite sides of the X.
Yeah, X.
Like this is not an X. This is a V and another V.
Yeah.
So is EGB and EGA, is it an X or is it more of it's a V, two Vs?
More of a V.
Okay, so that one's out. What about EGB and AGF?
AGF.
Yeah, the next one here.
That's like a big. It's like a. It's like a big X, I guess.
Okay, so it could be that one.
I guess.
All right, so the next one's the same, and so the last one is out. So now we got to go. Keep reading here. We're trying to figure out this last one. So it says angle AGF, AGF, and angle CHF are corresponding. So they're when they that corresponding here part is this right here. Those are corresponding. It's like lower left, lower left.
Yeah.
And congruent according to the corresponding angles theorem. So finally, that means angle EGB and CHF are congruent by the. Now, do you see any subtraction in this?
No, not at all.
None. So probably isn't that one. It is transitive. So let's quickly describe transitive property. I always like the analogy to if person A likes person B and person B likes person C, then A likes C, which actually may not be true. So, but that is the transitive property. It's like if A leads to B, B leads to C, then A leads to C. You'll see this in the movie tonight. You know, something happens that leads to this event leads to this event, so the initial event leads to that event.
That's cool.
That is
That's a cool way to think about it.
that is the transitive property. All right. Okay, so we've knocked that out. What else would you like to work on tonight?
All right. Do you mind fixing one of them?
Yeah, we should look and see what's wrong and take a look.
All right. We got number 7 wrong. I'll send it over to you.
Okay.
Ah, it's the one we guessed. Dang it.
Don't worry about it. You know, one missed question on one test on one thing in life isn't going to matter.
It was a 93. So, all right. So, those are all the assignments I have due this week, but we can go to Mondays because they already have it posted. So, I don't think it really.
Yeah, that's fine. I'll probably go a little slower on this new stuff just because I'm sure we are going through it too quickly anyway, but yeah, same format. You want to send over some things? We'll take a look at it here and
All right.
you follow the NBA?
NBA? No.
Yes.
I used to be really into football when I was a kid.
Draft
Or
is
no, that's
tonight.
no, that's NFL. NBA is basketball, right?
Yeah, basketball.
Okay, yeah.
The
I
draft is
get
tonight. Just didn't know if you cared or not.
no. I mean, I wish I was more into sports. I kind of just play video games. I'm just one of those guys.
What's your go-to game?
Go-to game? Probably Overwatch or Roblox, something. I don't know. Or like TF2, Team Fortress 2.
I've heard of all these. I used to be a gamer, but adult thing got in the way. So
Gamer.
yeah, I was. I mean, it's hard to believe, but I mean, I would miss work, play video games.
Dang, what'd you play?
So, I mean, this was back when PS3s were brand new. It didn't really matter. Just whatever the latest game was, get a group of people and you just play the night away.
Yeah, I get that.
But
Ever played that
easy.
one game? Sorry.
Which game?
I forgot the name, but as a kid, I was like really obsessed. It's like this guy that uses like lightnings, like I don't know, he has like lightning and he can like slide on power rails. And
Sonic?
no, not Sonic, no.
Sorry, that's what it sounded like.
No, I forgot the name of it. I'll look it up later, but
Sure.
yeah, no, as a kid, I was like obsessed with it. Sonic though, I played a lot of Sonic. I actually have a 3DS on my desk. It's like a Sonic
Oh,
racing game.
oh, cool.
Yeah.
I mean, it's still fun, I guess, every once in a while to do it, but you get older, you just don't have the time, and maybe that's the problem. We need to make the time to do stuff.
All right, I sent you over some of the questions.
Okay, here we go. Okay, a figure is translated 6 units to the left and 2 units down.
Oh, I've done this before.
Okay, why don't you see if one of these stands out to you then? Which one kind of looks
The
to be
bottom
that
one.
way?
Because to the left is negative and going down
That's
is
right.
negative.
That's correct. All right, so that's good. Let's look at the next one here. All right, unfortunately, again, kind of just they came in out of order here, so we'll just do 4 here. Triangle joy, Joy, is translated using the rule x plus 3, y minus 2. So that means to the right 3 and down 2. If a
Yeah.
line segment is drawn from point J to point J prime and from point O to O prime, which statement would best describe the line segments drawn? So there's almost no way to do this without making a drawing. So I've got the grid here, and I'm going to make a quick drawing of a triangle here. Okay, and we'll go J, O, Y, and now we're going to move every point to the right 3 and then down 2. So I'm going to start up at the top here. 1, 2, 3, down 2. 1, 2, 3, down 2. 1, 2, 3, down 2. Like that. So it's a lot like a movie. If you don't try to play it out, you will have no idea what's going on. Now, typically they use these primes. I don't think there's any relation to Optimus Prime, but there's the prime means new. Uh, the newer one. That's just the notation in math. So now it says we actually can do this now. A segment is drawn from point J to J prime. So I'll do that here in green, J to J prime. And a line segment is drawn from point O to O prime. What would you now look at the answers? Again, it's kind of, can you eliminate some? Maybe you see it. Maybe something's totally unreasonable.
Um, they look parallel, so I guess that's could
I
be
would say
one.
I'd say they're for sure parallel.
Oh, that's the answer.
That's the answer. There's no way to like, okay, so they don't have the same midpoint because the midpoints are up here.
Yeah, saw that.
They create diameters of concentric circles. Well, maybe, but we haven't talked about that, so that's out of scope. They're perpendicular to each other. Well, they don't intersect, so it's probably not that one. So kind of like a lot of the questions, if you can eliminate something, you can maybe get down to the answer on your own. Okay, new problem here. All right. So you play video games, you probably notice symmetries in games, symmetries in the layouts of different things that you're going through. Uh, programmers do have to do this. They flip, rotate, and stuff like that. This is like I'll give you the answer. I'll
I
tell
know
you
the
the answer.
answer. I know the
Well,
answer.
yeah. I was gonna say just give it a try here. It's gonna, what do you think?
Reflection across the x-axis.
Okay, so is that the only possible one that it could be?
Mm,
Could it be a translation vertical?
translation.
So a translation means a shift. Like,
could
look at this
be.
point up here. Is it shifted down a certain number of units?
Let's see. 1, 2, 3, 4, 5, 6. Well, it doesn't. I don't think it shifted down 15 units. I think it could
Could
be
it be shifted
10.
down 10 units? Is it exactly 10 units down?
2, 3, 4, 5, 6, 7, 8. It is.
It is. Now this one's somewhat deceptive. So I'm going to come over here. When I put this point right there in red, how many units above the x-axis is it?
2.
So the point over here, is it 2 units below?
Yeah. I know it's 3.
It's 3. Yeah. So they've done a really good job of being deceptive here. Because it does look like a reflection. And it almost is, but
Oh, I see that now. Okay.
it has to be, when it reflects, it's the same, every point is the same distance away. If it's 3 away, it's 3 away. If it's, 3 away, then it's gotta be 3 away.
Man, I thought I was
This,
smart.
no, this is a visual exercise. There's no intelligence in this. It's pattern recognition. It has
Yeah.
nothing to do with, nothing to do with like abilities in math. It's just some people see patterns, some don't. And some people see different patterns. You ever watched A Beautiful Mind math movie?
No, I haven't.
Okay, yeah, I mean, the most intelligent people in our world are often they see things that just you're glad you don't have that inside of you because it's a hard way to live.
Oh,
Way you sort of focus on things. So the answer here is the translation of 10 units.
yeah. But if it was, I have a question. If it was
Yep.
1 up, would it be a reflection?
Yes.
All right.
But because the object also has kind of this symmetry, it could actually be vertical translation of 9 units as well.
Yeah. What if it has like reflection and that? Would
It
it
could, yeah. So this
would they
course doesn't
both be
seem,
correct?
it would then say, they would say first like reflection over the x-axis, then a translation of 1 unit. That would then be correct.
Oh, okay.
It's also important to make sure you're always going from the old to the new. And the prime is the new. And this will happen in the next part of this course where you're doing dilations, which are enlargements or reductions. You always want to know what the new one is and the old one is. Where did we start? Where are we going?
Yeah.
All right, so here's a new question for us to look at. All right. This one's so wordy. So let's just say the origin is here. -2, 1 is there. And if we want to reflect it over the x-axis, it goes down there. And maybe you could use a line to do that. I don't know. I guess I don't want to just give you the answer. So just see if there's some words here that maybe indicate what's going on.
All right. Well, it looks like it's perpendicular to the y-axis if you have a line.
I would agree.
So,
Which answer would that be? Well, sorry. This is the x-axis. The y-axis is here.
yeah.
So perpendicular to, should be perpendicular to the x-axis.
Really? But like,
So here's x-axis, and then these are the perpendiculars.
oh.
And if you go the other direction, if you draw the y-axis, these are all perpendicular.
Oh, okay. I thought it meant like perpendicular, like, the other way.
That's parallel.
Parallel. Okay.
So parallel means they never intersect. Let's diagram that. So the streets, where do you live? If you don't mind me asking in part of Arizona?
Chandler.
Okay, so the streets there, like most everywhere else in the valley, is they're all parallel. A lot of them are parallel, right? But then some do intersect. But these are parallel, streets that run north-south, parallel. And then when you come to an intersection, that is perpendicular typically. Like if you go to Google Earth, you'll see that.
All right.
The rows, the seating in your theater tonight will be parallel.
Yeah, I just get those mixed up.
Yeah, it is important to know the difference between them. It's important to have that down. We talked about, Quizlet, note cards, something. You want to do something. You don't want to just kind of say, oh, I got it, because it will come back in this course.
Yeah, so it's perpendicular to the
It's
x-axis.
to the x-axis. That's my guess is that's my suggestion there. All right, let's see if we can knock this last one out here. All right, rectangle JKLM prime. So it came from this one over here. The JKLM turned into the J prime K prime L prime M prime. And then it says the same transformation we applied to trapezoid STV. So you have to figure out what happened. How did you go from the one on the left to the one on the right?
It moved over 18, or did it? It could be different. 1, 2.
So -7 to 6. It's like 13 to the right. And then how many down? So I'm going like that point to that point.
Yeah. $13, and then 3 down.
3 down.
Okay.
So because we care about point P, you need to take that point P, which is 5, 5, and go right 13 and then down 3.
Oh, you go right 13 with the T.
Yes.
So it'd be 18. And then you go down 3. It'd be 2. So +18, +2.
You got it. All right. So we do have to stop there for